Hello friends, welcome back to our channel. So today we'll see one more concept in dynamic programming, that is all pairs shortest path. So we can consider any graph and we are supposed to find the shortest path between all the vertices, right? So for example, if the graph is in this format, right? So this is a directed graph. Then we have to find out the shortest. If you select the vertex 1, we have to find out the shortest path from 1 to 2, 1 to 3 and 1 to 4. So the shortest, there might be a direct edge between the 1 and 2. If not, we have to find the shortest path from 1 to 2 using some intermediate node. For example, so here you can see there is no connection between 1 and 3, right? So there is no connection. So there is an edge between 1 and 2 and 1 and 4, but there is no edge between 1 and 3. So this can be computed that 1, 1 to 2, 2 to 3, right? So like that we have to find out the shortest path for all the vertices to all different vertices. So we have to consider first vertex and we have to find out the shortest path from this vertex to all the remaining vertex. And second, we have to consider the second vertex and we have to consider the shortest path from 2 to 1, 2 to 3 and 2 to 4, either direct or indirect. Direct means direct edge will be there, indirect means through intermediate node, right? And consider the third vertex and we have to find out shortest path from 1, 2 and 4. And consider the fourth vertex and find out the shortest path from 4 to 1, 2 and 3. So like that we have to find out the shortest path from one vertex to all the remaining vertices. So for this we are supposed to find the adjacency matrix, and from that adjacency matrix we are supposed to calculate all these things. So here we are using a one formula. Okay, so I'll write that formula first and then we'll apply that one, right? So I'll write the formula here. Example, a of 1 or k, a of k, that means the adjacency node k, right, is equal to, we have to consider a minimum of in between two terms. What is the first term? The first term will be a of k minus 1 I comma j, or a of k minus 1 I k plus a of k minus 1 k j, right? So we need to select either this one or this one. Simple logic. So this is a direct edge. Okay. So this will be the indirect. That means whatever the intermediate node we are taking. So if we are selecting 1 as a first vertex, so the k will be 1 itself, right? So by using the intermediate node, we are supposed to find the cost from I to j. Okay. So this is the thing. So I to j using intermediate via intermediate node k, right? Now, so this is ak of ij. So this is the main formula we need to do. So first step, we need to find the adjacency matrix. So find adjacency matrix. So we need to give the cost from one vertex to another vertex. So while finding the adjacency matrix, if there is no edge, if there is no edge, okay, if there is no edge from one vertex to another vertex, so fill it with infinity. If there is no direct edge, we have to fill it with infinity. And see, all self loops, self loops means if you consider the vertex 1, so what is the cost or what is the distance from one vertex 1 to vertex 1? Similarly, vertex 2 to vertex 2, vertex 3 to vertex 3, right? So all the self loops should be filled with 0. Should be filled with 0. So we have to remember these three things. First, we have to find the adjacency matrix. While finding the adjacency matrix, if there is no edge, so if there is an edge, directly we can give the distance there, right? So if there is no edge, fill the particular rows and columns with an infinity. So take the distance as an infinity. And for all the self loops, so from same vertex to the same vertex, right? So all self loops should be filled with a 0. So that will be A of 0. Okay, that's an initial adjacency matrix. And then we have to find out A1. That means considering the first vertex. So in that adjacency matrix of A1, okay, so we are finding the shortest path from 1 to remaining vertices. So A1 means, so this is an initial adjacency matrix. A of 1 means shortest path from vertex 1 to remaining vertices. Vertex 1 to remaining vertices. Similarly, from this one we have to calculate A2. So from this one we have to calculate A1. Okay, from this one A1 we have to calculate A2. So A2 means the shortest path from vertex 2 to remaining vertices, right? And this will be keeps on moving until it goes with the last vertex. A of n means the shortest path. So all these are adjacency matrix, right? So shortest path from vertex n to remaining vertices, right? So this should be happens, keep on moving until you find the adjacency matrix for all the vertices, right? So just remember this one, and we are going to use this formula. You can see A of k. So initially that will be 0, right? Initial adjacency matrix will be 0, A of 0. And from A of 0 we are supposed to find A1. So here k is 1 and k minus 1 is 0. K minus 1 is 0. K minus 1 is 0. So with the help of initial adjacency matrix we are finding out the A1. And with the help of A1 we are finding A2. With the help of A2 we are finding A3. So that should be keep on moving until it reaches to the all vertices. So finding of shortest path for all vertices, right? Now let us take an example. So I'll explain you. So let us calculate all these things, right? So let us take this example. So this is a small graph, directed graph. So the edges, the distance can also be a negative, right? The distance can also be the negative. So first let us write the initial adjacency matrix. So that is A0. So I'll write here. So 0, 1, 2, sorry, we'll write the vertices, right? So 1, 2, 3 and 4. 1, 2, 3 and 4. Fill out all those things, right? So 1 to 1, which is a self loop. Okay, so we have seen all the self loops should be filled with the zeros. So 1, 1, 0. 1 to 2, there is no edge from 1 to 2. There is an edge between 2 and 1, 2 to 1. There is no edge between 1 to 2. So if there is no edge, we have to fill with infinity. So 1 to 2, it is infinity. 1 to 3, yes, there is an edge between 1 to 3, it is 1. The distance is 1. 1 to 4, no edge. So simply use infinity. 2 to 1, 2 to 1, there is an edge, the distance is 3. 2 to 2, it is a self loop, so fill with 0. 2 to 3, there is no edge, fill with infinity. 2 to 4, there is no edge, fill with infinity. 3 to 1, 3 to 1, there is no edge, infinity. 3 to 2, 3 to 2, yes, there is an edge, so 2. 3 to 3 is a self loop, so 0. 3 to 4, no edge. 4 to 1, it is 5. 4 to 2, infinity. 4 to 3, 9. 4 to 4 self loop, it's 0. So this is the initial adjacency matrix. So we are calling it as A0, adjacency matrix, initial adjacency matrix. Now what we have to do, we have to find out the A1. So with the help of A0. So A1 should be calculated. So A1 means we have to find the shortest path from vertex 1 to all remaining vertices. So for that we have to do, so we have to keep the first row and first column as it is in the adjacency matrix. Okay, so where A1 is used to find the shortest path from first vertex to all the remaining vertices. So we have to keep the first row and first column as a same, right? So A1 will be having the values, so 1, 2, 3 and 4, 1, 2, 3 and 4. So keep the first row and first column. So the first row is 0, infinity, 1, infinity, column 3, infinity, 5. And see, these are the self loops, we have to go with a 0. So we need to find all the remaining items, okay, remaining places. So what is this place? 2, 3. So A1 of 2, 3 is equal to, so minimum of AK minus 1, A1 minus G1, 0 of 2 comma 3 and comma A0 of 2 comma 1 plus A0 of 1 comma 3. So we need to find the minimum from these two things. Okay, so we have to find the distance from 2 to 3 from A0, and here we need to find the distance from 2 to 1 in adjacency, initial adjacency matrix plus 1 to 3. So that means we are finding the edge of 2 to 3 with 1 as an intermediate node. With 1 as an intermediate node. So you can find out here. So minimum of, so from A0, say A2 to 3, A0 2 to 3, this is a A0 2 to 3, it's a infinity. And coming to this one, A0 to 1, 2 1, 2 to 1, it is a 3 plus 1 3, 1 3, it's a 1. So you can see we have to consider minimum of infinity and 4. So what will be the final thing? So it will be 4. That means the distance from 2 to 3 is infinity initially. So by using the first node, first vertex, so visiting from first vertex, right? So 2 to 3 with 1 as an intermediate node, it can travel from 2 to 1 and 1 to 3 with a distance of 4. So there is, among these two, this one is a minimum, right? 4 is a minimum. So fill that one here. So this will be 4. This will be 4. Now coming to the 2 4, we need to find out the 2 and 4. So what we have to do? Again the same procedure. A0 of 2 comma 4 is equal to minimum of, so A0 A1, right? A0 of 2 comma 4 direct this one, and A0 of 2 comma 1 plus a naught of 1 comma 4. So we are taking 1 as an intermediate node between 2 and 4. So from this one you can find out minimum of, so from a naught, what is a 2 4? 2 4, which is an infinity. And here 2 1, 2 1, it is a 3 plus 1 4, 1 4, it is an infinity. So simply you can see both are infinities. Both are infinities. So we can consider the infinity here. So I'll consider infinity only. Okay, I'll consider infinity only. So you can see from 2 4 using 1 there is no path. You can see the graph. So from 2 to 1 there is an edge, but 1 to 4 there is no edge. So that's why we got infinity here. Okay, then next this one 3 2. So a1 of 3 comma 2 is equal to a minimum of a naught 3 comma 2 and a naught 3 comma 1 plus a naught 1 comma 2. 1 has intermediate node between 3 and 2. So you can consider here minimum of, what is the 3 2 distance? 3 2. It's a 2. And a naught 3 1. 3 1. It's an infinity plus 1 2. 1 2. It's an infinity. So among these, which is the minimum? 2 is the minimum. So just keep the same here, 2. Okay. Now you have to find out this one. 3 4. 3 4, right? So a dash of 3 4, which gives a minimum value of a naught 3 4 and a naught 3 to 1 plus a naught 1 to 4. So you can consider minimum in adjacency matrix 0 3 4 3 4, which is an infinity, and 3 1 3 1, which is an infinity, plus 1 4, which is again infinity. Again we got infinity only. So that means there is no edge between 3 and 4 also by using in 1, right? So we got infinity here. Next, this one 4 2. Hope you understood. Just we are applying the same in this formula. So a1 of 4 2. So minimum of a naught 4 2. Similarly a naught 4 1 plus a naught 1 2. So a minimum of, what is the 4 2 distance? 4 2. It's an infinity. Next 4 1 distance. 4 1, it is a 5 plus 1 2. It's an infinity. Right? So 4 1 is there, but 1 to 2 there is no distance. So again we got an infinity. Place the infinity here. And next one 3. 3. So a1 of 4 3. We need to find the distance for 4 3. So we can consider here minimum of a naught 4 3, and also consider 1 as an intermediate node and find out the path a naught of 1 3. So a minimum of, you can find the distance from 4 3 in a naught. 4 3, it's a 9, and 4 1 it is 5 plus 1 3 it is 1. So 9 and 6, it is 6, right? So by using 1, okay, from 4, by using 1 you can go with the 6 distance, you can reach 3. So 4 to 1 5, 1 to 3 1 6. So minimum distance is 6. You can simply place here 6. So this adjacency matrix gives that from vertex 1 the shortest path to all remaining vertices. Okay. Now what we have to do? We have completed A1. Now we have to find out A2. Okay, A2. So what is this A2? Finding the shortest path from vertex 2 to all the remaining vertices. All the remaining vertices. For this also what we have to do? So we have to make use of A1 and we have to fix both the second row and second column. So what is the second row? Second row is 0, 3, 0, 4, infinity. Second column, infinity, 0, 2, infinity. And all the diagonals, self loops will be 0. We know that. And we need to find the remaining. So what is that? This one, A2 of 1, 3. 1 comma 3 is equal to a minimum of, what we have to do, we have to take the A1 because AK minus 1. So 2 minus 1 means 1. A1 of, what is this, 1 comma 3 or A1 of 1 comma 2 plus A1 of 2 comma 3. So we need to find the shortest distance, whether it is having 1, 2, 3 or by using the intermediate node 2. So here we are finding the shortest path from the second vertex. So the intermediate node will be 2. So we can find out here a minimum of, what's the value of A1, 3 from A1. This from here, 1, 3, it is 1. 1 to 3, it is 1. A1, 2, 1 to 2, it is infinity, plus 2 to 3, it's a 4. So obviously this will be infinity, so this will be the minimum. So fill that one here, 1. Right? Next, A of 1, 4. Okay, we need to find A2 of 1, 4. So that will be a minimum of A1 of 1 comma 4 or A1 of 1 comma 2 using intermediate node plus A1 of 2 comma 4. So we need to select the minimum among these two. So from A1, what is the 1, 4 distance? 1 to 4 distance is an infinity. From A1, 1 to 2, 1 to 2, again it is an infinity, plus 2 to 4, again it's an infinity. So obviously what happens? Infinity. So place the infinity here. Okay. The next one. We need to find A2 of 3, 1. 3, 1. So what we have to find? So minimum of either direct edge from adjacency matrix 1 or by using the intermediate node 2, 3, 2 plus A1 of 2, 1. So what, is there any edge? 3, 1 from A1. 3, 1. It's an infinity. A1, 3, 2. 3, 2. It's a 2 plus 2, 1. 2, 1. It's a 3. We have to find out the minimum among these two. Obviously, it will be 5. So you can see the distance from 3 to 1. So distance from 3 to 1. Okay. There is no edge. So by using the intermediate node 2, there is a distance 5. So that's what we are finding out. So fill it with here 5. And next, find out the value of 4. 3, 4. So A2 of 3, 4, which is a minimum of, what we have to do? A1 of 3, 4 and A1 of 3, 2 plus A1 of 2, 4. So we need to find out the minimum among these two. So minimum of 3, 4 from A1, 3, 4 from A1, it is an infinity. 3, 2 from A1, 3, 2 from A1, it is 2 plus 2, 4, it's an infinity. So which is infinity. So from 3 to 4, there is no cost. 3 to 4. By using intermediate node, there is no edge from 2 to 4 also. That's why otherwise we will be having infinity. And next, we need to find two more values, that is a 4, 1 and 4, 3. So A2 of 4, 1, which will be a minimum of A1 4, 1 and A1 4, 2 plus A1 2, 1. So what we have to do? Minimum of 4, 1. What's the cost between 4 and 1? So 4 and 1, it's a 5. And 4, 2 with the intermediate node, 4, 2, it's an infinity plus 2, 1, 2, 1, it's a 3. So obviously this will be infinity and this will be the minimum, so 5. So you can simply take it as a 5. And now the next one, 4, 3. Find out the 4, 3. So A2 of 4, 3. So which gives the minimum value from the direct edge or using intermediate node. So A1 4, 3 or A1 4, 2 plus A1 2 comma 3. So from A1, what is that? 4 comma 3. So 4 3 distance is 6, and 4 2 distance is infinity, plus 2 3 2 3 distance is 4. So obviously this will be infinity, and this is a minimum, right? So 6 will be the result, and that will be stored here. So this adjacency matrix indicates the shortest path from 2 to all the remaining vertices. Now what we have to do, again we have to calculate the A3. A3. That means we have to find out the shortest path from third vertex to all the remaining vertices. For this we have to use a A2. So 1, 2, 3, 4. 1, 2, 3, 4. So what we have to do, we have to keep the third row and third column in the same from A2. So from A2, what is the third column? So 5, third row, 5 to 0, infinity. Third column, so 1, 4, 0, 6. And we know that the self loop, we are having zeros. And we need to find out all these elements. So A3 of this one, 1, 2, 1 comma 2, we have to find out a minimum of A2 from the matrix 2, 1 comma 2, or A2 of, take the 3 as an intermediate node and find out the distance, A2 of 3 comma 2. So a minimum of, consider 1 2 distance from 2, 1 2 is an infinity. And what about the next one, A2 1 3? A2 1 3, it is 1 plus A2 3 2. A2 3 2, it's a 2. So which gives a 3. So we need to fill the value. 3 is a minimum among infinity and 3. So 3 should be here. So you can check from 1 to 2 with the index 3. Okay, with the intermediate node 3. So there is no direct edge from 1 to 2. So in order to reach 2, what is the minimum cost? 1 2 3, 3 2 2. So 1 2 3 is 1, 3 to 2 is 2. So total 3, distance 3. Okay. Next, we need to find out the distance of 1 4. So A3 1 comma 4, which is nothing but minimum of, okay, so A2 1 comma 4, and similarly A2 1 comma 3 plus A2 3 comma 4. So from A2 1 4, what's the 1 4? It's an infinity. Coming to this one, A2 1 3, A2 1 3, it is 1 plus 3 4, 3 and 4, it's again infinity, right? So obviously the result will be infinity, so you can just fill with the infinity only. Okay, so there is no path by taking 3 as an intermediate node, right? From 1 to 4. So 1 to 4, you can go from 1 to 3, but there is no edge between 3 and 4. So obviously it will come infinity. The next one, 2 1. A3 of 2 comma 1. So which gives a minimum A2 2 1 or A2 2 3 plus A2 3 1. So taking 3 as an intermediate node. So from adjacency matrix 2 2 1 2 1, it is a 3, and A2 2 3 2 3, it's a 4 plus 3 1, it's a 5. So you can see we have to consider the minimum, right? Minimum. So obviously 3 will be the minimum. So we can have a path from 2 to 1. From 2 to 1, there is a direct edge, or with the help of 2 to 3 and 3 to 1. Okay, 2 to 3 and 3 to 1. So 2 to 3 means 2 to 3, it's a 4, right? How we are getting 4? So from adjacency matrix 1. So obviously from here we are not having 2 to 3, right? So if you want to reach 3, we can go with the 2 to 1 and 1 to 3. So for that we are having 4. So with that cost also we cannot reach 1 from 2, right? With a 3 as an intermediate node. So 3 and 9. So obviously the 3 will be the minimum value. So fill the 3 here. Okay, hope you understood. So here the edge from 2 to 1, there is 2 to 1, there is a direct edge, And we are also checking whether there is an edge with a minimum cost if you consider 3 as an intermediate node. So we are not having that one. Next, so A3 to 4 is equal to minimum of A2 to 4 or A2 2 comma 3 plus A2 3 comma 4. So you can check minimum of A24 2 4, sorry, this one 2 4, it is an infinity. Similarly 2 3 2 3, it's a 4 plus 3 4 3 4, again it's an infinity. So obviously there is no edge, right? Next 4 1, we have to find out 4 1. So A3 4 1, which will select a minimum from A2 4 1 or A2 4 3 plus A2 3 1. So what we are doing, A2 4 1 4 1, it is a 5, and A2 4 3, it's a 6 plus 3 1, it's a 5. So you can see there is a direct edge with a minimum cost, and if you are taking 3 as an intermediate node, the distance will be more. That means 11, it becomes 11. So we should consider only 5. So fill with 5. And again 4 2, we have to consider 4 2. So A3 is equal to, A3 of 4 2, which should be considered minimum value from A2 4 2 or adjacency matrix 2 with a intermediate node 3 4 3 plus A2 3 2. So minimum of, you can select A2 4 2. In A2 4 2, it is an infinity. A2 4 3, it is a 6 plus A2 3 2 2 8. So 2. So obviously it will be 8. So fill here 8. Okay. So hope you understood this one, right? Next, find out the A4 adjacency matrix 4, so that we have to consider right. So we have to make the fourth vertex, fourth row and fourth column as a constant, right? 5 8 6 0. Similarly infinity infinity infinity. So you can check 1 to 4, there is a no path. Okay, so there is no path. If you go with a 2 also, there is no path. If you go with a 3 also, there is no path to 4. So that's why we got an infinity. And 2 infinity, from 2 also there is a 2, and if you go with the intermediate node 1, so 2 to 1, there is no edge from 1 to 4. Here also there is no edge from 2 to 3, right? So obviously that will be infinity. Similarly 3 infinity, so 3 to 4, there is no edge. If you consider 2 as a intermediate node, 3 2, yes. From 2, if you take 1 as an intermediate node, yes. From 1 there is no edge to 4. So there is no connectivity from 3 to 4. That's why we got an infinity. So infinity means there is no path. There is no path. And see, coming to here, what we have to do? So the self loops, it will be zeros. And we have to find these things, right? So A4 of 1 2 is equal to minimum of, what we have to do? So A3 of 1 comma 2 or A3 of 1 comma 3 plus A3 of 3 comma 2. So making 3 as an intermediate node. Okay, sorry, it's a 4, right? So we are taking 4 as an intermediate node. So 1 4 and 4 2, right? So what we have to do? So minimum of, you can consider from A3 1 2. 1 2 means it's a 3, and A3 1 4. 1 4 is infinity, plus 4 2. 4 2 is 8. So obviously 3 and infinity, 3 is a minimum, so you can fill it with 3. Okay. Next, find out the A4 of 1 3. 1 3 is equal to minimum of A3 of 1 3 or A3 of 1 4 plus A3 of 4 3. So taking 4 as an intermediate node. So minimum of A3 1 3. So in A3 1 3 it is a 1. And coming to 1 4, 1 4 it is an infinity. Plus 4 3, 4 3 it is a 6. So 1 will be the result. So here you can take it as a 1. Okay. Now coming to the next one, 2 1. So A4 2 comma 1. So it will be a minimum from A3 2 comma 1 or A3 2 comma 4 plus A3 4 comma 1. So which will be taken as minimum of A3 to 1. 2 1 it's a 3. A3 to 4. 2 4 it's an infinity. Plus 4 1 it's a 5. So obviously this is a minimum. So simply consider 3 here. And similarly A4 2 3 is equal to minimum of A3 2 3 or A3 2 comma 4 plus A3 4 comma 3. And you can see the cost from 2 3 in adjacency matrix 3, 2 3 it is a 4 and 2 4 it's a infinity plus 4 3 it's a 6. So obviously this will be infinity and 4 should be taken. So 4 will be filled here. Okay. Next 3 1. So A4 of 3 comma 1 which will be taken from minimum A3 3 comma 1 or A3 3 comma 4 plus A3 4 comma 1. So from this you can see minimum of A3 3 1. 3 1 it's a 5 and A3 3 4. 3 4 it's an infinity plus 4 1 it's a 5. So 5 will be the minimum because infinity plus something will be infinity. So 5 we can go with the 5. And next and the last one, A4 of 3 2 is equal to the minimum of A3 3 comma 2 or A3 3 comma 4 plus A3 4 comma 2. So what will be the value? Minimum of A3 2. So in the adjacency matrix 3 3 2 it's a 2. 3 4 see infinity plus 4 2 which is a 8. So obviously 2 will be the minimum. So you can write it as 2. Right. So this is the final adjacency matrix where all the vertices can be visited with a shortest path from one vertex with all other vertices. So you can see 1 to 1 0. So 1 to 2. If there is no direct edge between, okay, there is no direct edge between 1 and 2, but the shortest distance is 1 to 3 and 3 to 2. The cost is 3. Okay, initially it is infinity. Now with a minimum cost 3, the person can visit from 1 to 2. Similarly, 1 to 3 there is a direct, 1 to 4 there is no edge, 2 to 1, 2 to 3. Coming to 2 to 3. So if 2 to 3, we can reach 3 with a minimum cost with using 1 as an intermediate node, 2 to 1 and 1 to 3. So 3 plus 1 it's a 4. So this is the final adjacency matrix which gives the shortest path from one vertex to all other vertices. Right? So hope you understood. So infinity, here infinity means there is no way to reach from 1 to 4 by using intermediate nodes also. So you can see 1 to 4. So 1 to 4. So there is no outgoing edge from 1 to 2 or 1 to 4. There is an outgoing edge from 1 to 3. So you can consider 1 to 3 and you have to check whether there is an edge between 3 to 4. So from 3 there is no outgoing edge, you can observe. There is no outgoing edge. So it is impossible to reach 4 from 1. So in such cases we are filling with a infinity. The same case comes with a 2 to 4. So it is impossible to reach from 2 to vertex 4. Okay, in this example, in this particular example. So based upon the given graph, you have to draw all these things. So you have to find out all these things. So find out the initial adjacency matrix. With the help of initial adjacency matrix, you have to find out the A1 considering the first vertex as a constant, as an intermediate node, and finding all the shortest path from 1 to all the remaining vertices. And from this A1, we have to find out the A2, which means taking 2 as an intermediate node and finding all the shortest distance from vertex 2 to all the remaining vertices. And after calculating A2, with the help of A2, we have to find out the A3, which means 3 is an intermediate node. Vertex 3 will be an intermediate node, and we are finding the shortest path from vertex 3 to all the remaining vertices. And after calculating A3, we have to find out A4, which means fourth vertex is the intermediate node, and we are finding the shortest path from vertex 4 to all the remaining vertices. So here we are having only 4 vertices, so we have calculated from A1 to A4. A0 is the initial adjacency matrix, right? So final A4 gives the shortest distance from one vertex to all other vertices, right? So let's stop here, and hope you enjoyed the session. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.